cases when it comes to absolute value inequalities. The first case is when it's greater than or equal to or just greater than. So let's just logically think about this for a second. If the absolute value of a number is greater than or equal to 7, what are some of our options? Like what values would work there? 7 obviously works because it's equal to, whoops, that's not 7, that's 5. I heard somebody say 8, okay, 9, we could keep going in that direction. So we have everything that's bigger than 7 works. Is there anything else? Are those the only values that are going to work?
-7.
-7. The absolute value of -7 is +7. So then that means -8 is going to work, -9 is going to work, all these values down here as well. So we kind of end up with the ends of our spectrum. Now we're really going to focus on the interval notation because they really love the interval notation with the Math 3. So I think the number line really helps with this. On the left side, of course, we have negative infinity. On the right side, we have positive infinity. So we start on the left. We start with negative infinity. We go until we get to -7. We can equal -7, so we get a bracket there. Then we've got this gap, and it picks back up at +7. Again, we have a bracket, and then we continue on to positive infinity. So any number in those intervals will satisfy that absolute value inequality. Our other case is when the absolute value is less than or equal to. So let's think of some values here. The absolute value is less than or equal to 4. Obviously 4 is going to work. 2, 3, okay. What else? -4. -3, 0, okay? Any of those values are going to satisfy that inequality. So we have kind of a sandwich here. We have all these values that are between -4 and +4 are going to satisfy this inequality. So, excuse me, the interval notation for this one is from -4 to +4, brackets on each end because it is equal to -4. We can include -4 and +4 and anything in between. All right, so we're not going to worry about those two lines there in the middle because we haven't really been doing inequalities up to this point. Okay, so our steps to solve. Number 1, just like with our equations, we've got to isolate that absolute value expression. We've got to get it by itself if necessary. A lot of them we don't actually have to do that. We get 2 cases just like we do with the equations. The first case, just like with the equation, you just keep everything the same. The second one, we're going to use, this acronym works pretty well. It's KISS, keep it, switch, switch. So you're going to keep what's inside the absolute value, you're going to switch the inequality, and you're going to switch what's on the other side. Switch the sign of what's on the other side. And then you're going to solve both, graph the solutions, and put in interval notation. All right, so let's look at example number 1 here. We have the absolute value of x plus 6 is greater than 7. The absolute value is already isolated, so no work to do there. So let's just set up our 2 cases. For the first case, we keep everything the same. We just drop the absolute value bars. That's the only thing we have to do is drop the absolute value bars. Okay, for the second case, we keep what's inside the absolute value the same. We switch the inequality, so this time it's less than, and we switch the sign of what's on the other side, less than -7. Then we just solve those 2 inequalities just like we solved our 2 equations before. Subtract 6 from both sides. X is greater than 1. I always wait until I get to the end before I graph it so that I can see what's going on here. Subtract 6 from both sides. X is less than -13. There are no equal to's on this one. So on these values, we're going to put open circles. At -13, less than, so we shade to the left, less than, left. The L's go together. X is greater than 1, Open circle on 1, greater than, to the right. Greater ends with an R. R is right. Or look at the arrows, okay? With the inequalities, they kind of point, when the variable's on the left, it points in the direction that you should be shading. So for our interval notation, and I think this helps some people too, to put negative infinity on the left side of the number line, positive infinity on the right side of the number line, okay? And then go left to right. Negative infinity, comma, negative 13, parentheses around the negative 13, because we're not equal to negative 13. And then we've got our gap. We pick back up at 1, parentheses with the 1, because we're not equal to 1, to positive infinity. Infinities always get the parentheses, because they're not actually a number. It's just a concept. Okay, pretty simple, right? You've got to remember those details. Number 2, already isolated, nothing to do there. Let's set up our 2 cases. 2b minus 3 less than 19. KISS, keep it, 2b minus 3, switch the inequality, greater than, switch the sign, negative 19. Solve our 2 cases. Add 3 to both sides, 2v is less than 22, divide by 2, v is less than 11. Other case, add 3 to both sides, 2v is greater than negative 16, divide by 2, v is greater than negative 8. This one started as a less than. Less than is the one that gets sandwiched. So we are less than 11, between 10 and 12 there, and we are greater than negative 8. Open circles, because there are no equal to's. We are greater than negative 8, and we are less than 11. So we are between those 2 values. So our interval notation, negative 8 to positive 11. Now, notice, all of these number lines are not exactly the same. They don't have the exact same scale on them. So use that as a little hint. If you get a number that's not on the number line, something probably went wrong when you were solving. So go back and check your numbers if yours don't fit on the number line. Okay? All right. Number 3 and 4. Again, nothing to do to isolate. So we set up our 2 cases, negative 5. Let me change my color here. Negative 5 plus k over 3 greater than or equal to 1. KISS, keep it. Negative 5 plus k over 3. Switch the direction of the inequality. Switch the sign of the right side. So we add 5 to both sides, k over 3 greater than or equal to 6. What do we do to finish that one off? Multiply by 3 on both sides, so k is greater than or equal to 18, right on the edge of our number line. Other scenario, add 5 to both sides, k over 3 less than or equal to 4, times 3, times 3, k is less than or equal to 12. So less than or equal to 12, greater than or equal to 18. So we've got negative infinity to 12, bracket, because it's equal to, bracket 18 to infinity. Now, I really haven't talked about checking these. Obviously, you can plug in those 2 numbers and see if they equal 1 to check the direction of your inequality. Pick a number that's in your shaded region. So within our shaded region here, what's the easiest number to plug in? 0. 0 is usually the easiest number ever to plug in. So if we plug in 0 for k, 0 divided by 3 is 0, negative 5 plus 0 is negative 5. The absolute value of negative 5 is positive 5. It's positive 5 greater than or equal to 1. Yes. So that means that we shaded in the right direction there. You could also check something to the right of 18, but if that one's right, then the other one's probably right. All right, let's look at number 4. Number 4 is going to remind us of something we have to remember with inequalities. It's already isolated, so we set up our two scenarios. 7 minus 4n is less than or equal to 27. Keep it, switch, switch. All right, let's solve. Subtract 7 from both sides, negative 4n, less than or equal to 20. Divide by negative 4. What do we have to do when we divide by a negative number? Switch the inequality. Okay, that's what will throw most people off on these equations, or excuse me, on these inequalities, is that they divide by a negative number or multiply by a negative number. They forget to flip that inequality. So we've got n is greater than or equal to negative 5. Subtract 7 from both sides. We get negative 34. Divide both sides by negative 4. We divide by a negative again, so we flip it. Negative divided by negative is a positive. 34 divided by 4 does not go evenly. That's 17 over 2, which is 8.5. The decimal's more useful to us since we are graphing on a number line. We are greater than or equal to negative 5, and we are less than or equal to 8.5. So we are between those two numbers there. So negative 5, I like fractions, so I'm going to put that back as 17 over 2. If you put the decimal, I'm not going to count it wrong. I'm not going to count points off. I just like fractions better. They're neater. Okay. All right. Pretty easy, right? Let's keep going. Finally, some where we have to do a little bit of work before we split it into the two scenarios. Okay, absolute value of q minus 1 over 4 greater than or equal to 2. We need to begin by multiplying both sides by 4. So we have the absolute value of q minus 1 greater than or equal to 8. Split it into the two cases. Q minus 1, why did I flip that? I'm getting ahead of myself. Greater than or equal to 8. Keep it the same. Keep everything the same. Second scenario, KISS. Keep it, switch it, switch it. Simple to solve. Add 1 to both sides. Q is greater than or equal to 9. Add 1. Q is less than or equal to negative 7. We are equal to, so solid to the left. Greater than or equal to 9, solid to the right. So interval notation, negative infinity to negative 7, 9 to positive infinity. Number 6, subtract 3 from both sides. Absolute value of 8a plus 10, less than 22. Two cases, 8a plus 10, less than 22. 8a plus 10, greater than negative 22. Subtract 10, 8a is less than 12, divide by 8, 3 over 2, or 1.5. Subtract 10, 8a is greater than negative 32, divide by 8, a is greater than negative 4. This is an in-betweener because it was less than, so greater than negative 4, less than 1.5. Parentheses with our interval notation because we didn't have any equal to's. Okay, I know y'all are getting bored. I'm going to do one more with you, and then I'm going to let y'all do the rest of them. Because I want to make sure that we start number 7 correctly. I think everybody knows we need to divide by negative 10, but please, please, please do not forget even though this is the very first step, when you divide by negative 10, that inequality has to change directions. If you don't, you're not going to end up, you're still going to get the right numbers, but you're not going to have the right directions when it comes to your number line and your interval notation. Okay, so two cases, 2r minus 1 greater than or equal to 6, 2r minus 1 less than or equal to negative 6. Add 1, 2r greater than or equal to 7. Divide by 2, r is greater than or equal to 3.5. Add 1, 2r less than or equal to negative 5. R is less than or equal to negative 2.5. So we end up with the ends here. Because after we isolated the absolute value, it was greater than or equal to. So greater than or equal to is going to give us the ends. The original one was less than, but that negative number flipped it around. Okay, so our interval notation, negative infinity, negative 2.5 with a bracket 3.5 to infinity.